The ASCENDS acronym is the name of this mission for measuring carbon dioxide. Yeah, so one of the exciting things about this project is that you can actually watch trees eat and breathe. Of course, trees are breathing all the time, but they're only eating, meaning performing photosynthesis, when the sun is out. The main science is to measure how much carbon dioxide there is in the atmosphere at this particular time on the Earth. How much is there total, and where is it located? Turns out that when you burn materials, then a lot of carbon dioxide comes off. So if you could see it, it would look like smoke, and it stays. It's also a little heavier than the air. It stays in the lower part of the atmosphere. And that carbon dioxide has been tied into warming of the atmosphere. That's a key interest to us on the planet. The great thing about a laser instrument is that it can make the measurement both in the daytime and in the nighttime, because it's its own light source. So it doesn't count on the sun being out to make these measurements. The way that we evolved the carbon dioxide instrument is we use a small gas cylinder. By doing that, we can put a controlled amount of carbon dioxide in there, basically 100%. And it allows us to make that measurement, which we're ultimately going to measure from space, it allows us to make it in a controlled way, not using air, but with a big absorption in a very small physical footprint, so we can do the measurement on our lab bench. Then the next step is we make measurements across the parking lot. We hang the targets on the cell phone tower, and then we direct our laser beam to that tower. The light hits the target, comes back to us. Now we can measure all of the light in the column of air between our laboratory and the cell phone tower. The amount of data coming down from the carbon dioxide sounder is not an unwieldy amount. Again, we're interested in measuring 10 kilometer squares on the Earth averaged over a month, and then measuring how much carbon dioxide is there. So typically our job here is to look at what's happening in the commercial field, what's happening elsewhere in the government, and try to leverage that to build a science instrument. We're doing our best to make use of the resources that are there, but also we want to see what technology is going to evolve without a lot of additional funding, so that we can take advantage of its evolution. But now we're talking about maybe making that measurement from Mars as well. The carbon dioxide instrument is probably one of the most exciting things that anybody could be working on at this time in history. We have this new technology, the fiber lasers, to work on it. We have this incredible need to measure the health of the Earth over time. We have this great place, NASA, that's set up to bring the scientists and the technologists together to do that. It just doesn't get much better than that. I mean, everything's come together. There's great synergy there.